Hello and welcome to the micro lecture on data preparation. In this micro lecture you will learn how to identify and distinguish common data types, and we will focus on tabular datasets, so this will not apply to datasets that you, for example, prepare for computer vision. Then you will learn something about handling missing data and one-hot encoding, which you need for specific data types. And last but not least, we will talk about outlier detection. Subsequently, we will start with different data types: one-hot encoding, missing data, data imputation, and outlier analysis. With the data you have available that are not missing, it is very important to look out for the data types. So there are different kinds of data types. Data can be either numerical, so an integer or a float. There can also be categorical data. For example, on the slide before we saw different countries. That would be a nominal data type. It can also be ordinal, so that you can have any kind of ranking or order. Then there are Boolean data, so they are binary and can only be one of two values, for example, either true or false, or 0 or 1. Then you have text data, and you can also have datetime data. There are also other data types, but these are the most commonly used ones. So usually machine learning algorithms cannot handle categorical data very well, or they need them transferred in some kind of way in order to process the information. So for example, if you have a data set that includes observations, for example, from products, and usually you would have one table that says color, and then in this column of color you would have written, red, green, or blue. Then it's difficult for some machine learning algorithms to process the information in that format. What you can do instead is so-called one-hot encoding. That means that for every possible value of your categorical variable, you insert another column which basically says only the value, and then you encode it with 0 or 1s only, meaning there is a 1 if the product has this certain color and 0 otherwise. So usually in these new columns there should only be a 1 in every row of these new columns. Here on the slide you can see an example where you have these pictures, and then in the first row the color is obviously red, and therefore you have in the column red there is the 1. And you usually need this for classification tasks, but you can also apply it in image recognition and time series analysis. Usually when dealing with real-world data, you'll encounter missing data in your dataset. In Python they are displayed with NRN, which stands for not a number. And there are multiple reasons why data could be missing. If the data are collected manually, maybe just someone forgot to insert the data. If they are collected by sensors, then maybe there is an error in the system, or maybe a sensor was defect. So usually it's hard to get the reason afterwards, but nevertheless you have to decide on how to handle the missing data. Before deciding that, it might be advisable to count the missing data in your dataset, because your measures should also depend on how many missing data you have. If you just process your data without handling the missing values, that can lead to either bias or the reduction of the accuracy of the data models, which you don't want. So you need to decide what to do with those. One option is simply to drop the missing data. So for example, if you have a column where 90% of the data are missing, then you could drop the whole column. Same with rows. For example, in the example above, you see the last row has many NRNs, so it might be advisable to just drop the entire row. However, before doing so, you should consider the information loss. So, do you still have enough data if you drop this information? Because there are also other possibilities than just dropping them, which we will talk about in a second. If you don't want to drop columns or rows with missing data, you could use data imputation. Data imputation is a class of procedures that aims to fill the missing values with estimated ones. So basically it allows you to preserve as much data and also to improve the data integrity. So first of all, you should use all the information you have available to fill the missing data. In this example below, you could check that Ireland is in Europe. So basically see if you can research the information anywhere. That is usually not the case. Thus you would apply any kind of statistical techniques, for example. Very common is the mean, median, or mode imputation for numerical values. So if you have a numerical variable and any missing data, you would just insert the mean, median, or mode. But there are also more advanced methods, for example, that you could train a model on the leftover data, so on the data which are not missing, to estimate the probable value for that cell. Outlier detection is important because outliers are data points that are significantly different from the remaining data. And that means that they usually contain valuable information. Either the data point is an error, which might sometimes happen, so that you have for example, if you deal with numerical values, extremely high or low value due to some measurement error, or they are, let's say, very interesting data points. So outlier detection is, for example, used for intrusion detection systems or also for credit card fraud. So if the algorithm looks at all the payments which have been made by a credit card and then finds one, I don't know, where the location is very unusual or something else, then it flags the transfer and usually the credit card owner gets a notification. The output of an outlier detection algorithm can be two types. So either it's like binary, so it just says, okay, this data point is an outlier or not, or you might have an outlier score, which means that the data point gets a number assigned, which signifies how likely or how likely it is an outlier, or how unusual the data point is. Both can be interesting to observe or to dig deeper in what happens in that observation. There are different models and methods to detect outliers. For example, the extreme value analysis is very common. And then you also have several probabilistic and statistical models. So it's important that you find the method that suits your dataset. And then after you found outliers, it's also an important decision whether to remove them or to transform them. So if after further investigation you've come to the conclusion that the data point that was flagged as outlier is just an error, so there was a measurement error, for example, then you could either just remove the entire observation if you have enough data. That's a very plausible decision. Or sometimes you can also transform the data. So, for example, you impute it with a mean. You can't do that. It has the disadvantage of deterring your data distribution. So, just think carefully on how many outliers you have and what implications that would have on your further data analysis. A very popular method to detect outliers is the interquartile range method. So it basically calculates several statistical measures, for example, the median and the quantiles, and then it subtracts and adds 1.5 times the interquartile range to the median. And then all the values that are below the difference or above the sum are marked as outliers. So, in this micro lectures, you learned something about different data types in tabular datasets. You learned how to handle missing values and how to apply one-hot encoding. And last but not least, we talked about outlier detections and how to manage outliers. Thank you very much for your attention.